Hello guys, welcome back to my YouTube channel. Today I'm going to explain about the quicksort. This is one of the sorting algorithm which is used to sort an array. You heard about what is sorting? What is sorting means arranging the elements in a particular order. In particular order. Order means that would be ascending or descending. Ascending means lower to higher. The numbers will be lower to higher. Means like this 1, 2, 3, 4, and so on, like 100. Descending means the opposite of ascending, like 100, 99, so on, 1. This is descending order. So I think you got an idea about this sorting. After this, quicksort. So quicksort is one of the sorting algorithm. Algorithm means set of instructions. Set of instructions. Why we use this set of instructions? To solve an issue, to solve a problem, to build an logic, we use some instructions. Those instructions we call it as a algorithms. Clear? Now let's see the first pseudocode of the quicksort. Pseudocode of quicksort. In this, first let's see the algorithm first. Then after pseudocode. In this algorithm, first in this quicksort, what we have to do? So based on one element, we do the sorting. What is that element? That element we call it as a pivot. This pivot can be first element and random element in array and last element based on our requirement. We can choose pivot as a first element and a random element and the last element. Then after that, based on this pivot, we find the left boundary and right boundary. In the middle of this left boundary and right boundary, we call it as a pivot also. Yeah. First, let's choose the first element as a here in this tutorial. I would like to choose the first element as a pivot. Then I will explain the problem and algorithm for this. And then we'll write a code in Java on this quicksort with first element as a pivot. Then here, what we have to do, when you select the pivot element, then you have to compare left boundary and right boundary. Here we have to take 2 pointers to compare this pivot, left and right element, or I or j, whatever you want. First, start from 0 and j is size of array, size of array. Here I am starting from 0. Then from this, when we are going to comparing this from left to right, we have to check first I is less than or equals to I. I means this size of an array, and also array of ith element is less than or equals to pivot element. If this condition is true, then no need to do anything, just move this I to forward. Yeah. And one more condition, in this while, we have to do the while loop. We have to check this condition in the loop, while loop. And another while loop is why? Because just we are checking these elements are left side or right side. This elements belongs to left side or right side. Just we are checking that elements for left boundary, and for right boundary, what we have to do? First, check the one condition. Main condition is j is greater than or equals to low. Okay, because it will otherwise it will return the array index out of bound exceptions like that. So that's why I'm writing this first condition here. After that, array of j is greater than, just I am saying greater than pivot. Then move j plus plus. Understood? Just with help of this condition, with help of this loop, we are checking the right boundary contain higher elements or not. One more thing, here I am using the less than or equals to, and here just I am using the greater than. Why? What is the main concept behind it? Because only the duplicates elements. Let's consider 4 comma 4. Sorry, 4 comma 4 comma 4 is there. Sorry, my bad. Yeah. Suppose if we not consider this less than or equal condition, so what will happen? 4 4 is less than 4. Is this correct? No. So then it will stop here only. So here I am using the loop, while loop. So it will not move forward. So just here only it will check. So the infinity condition will happen here. So that's why I'm using the left. So and also the lower elements. These are the lower elements. For suppose 5 is a pivot element. At that moment, what we have to do? These lower elements have to consider left side. Our pivot is 4. Then this this condition will not move forward now. So that's why here I am checking the less than or equals. So these all the elements we consider as a lower elements. So that's why we are using less than or equal. And here I am not using any greater than or equal. Why? Because if I use that condition, then what will happen? So like for this only consider this. Like 4 is the pivot. So 4 is greater than or equals to 4. So this is true. So that's why it will move to 0 index. So this will not stop. So this will also give the one exception. So that's why I'm taking this less than or equal. I'm just considering like lower elements considered to left boundary and higher elements considered to right boundary. Yeah. This is a logic behind the quicksort. Then after that, I hope you understood the what will happen in the quicksort. So then just let's see the algorithm further, and let's consider this one as a pseudocode also. Pseudocode. First, what we have to do, we have to take one array. What is that? 7. Here I have already taken one array. 7, 3, 9, 4, 8, 2, 6. This is an array. First, what we have to call quicksort. In that we have to pass this array and low and high minus 1. What is this low and high? Low means 0 and high means array dot length minus 1. Then after that, call this quicksort. I'm creating this quicksort method, and low is there and high is there. In this method, first we have to check this condition here. If low is less than high or not, then only do this action. Otherwise, we will get exceptions. Again, here I am using the recursion concept for this. Just here we have to call one more function, that is partition, to find the partition. Partition means it will identify the best correct part of the correct index of the pivot. For that, I'm passing this nums low and high. After that, you will get the correct position of the pivot. Then what you have to do after getting the pivot position, again you have to check left boundary and right boundaries are still, is there any sorting you have to perform. For that, same nums and low, from where to start? In the left boundary we have to start from low to partition minus 1. So remove this position element because already the pivot element settled a particular position, so no need to check that element. So in the same way, quicksort nums, where you have to start partition plus 1 into high. Then after that, one more method is there, that is pick. In this, the main action will happen. This is for find the best correct position of the pivot, norms, low and high. Here, in the starting, I told you, like the pivot element, I am considering this first element, like norms of low. This is the first element I am considering the pivot. Then after I is equals to low and j is equals to high. In this method, I have to write one condition while I is less than j or not. So if it is true, then check the left boundaries. I mean compare with, yeah, just compare with pivot. This left elements, just compare with main pivot element. For that, first check the condition. I have previously I have told you, like I is less than or equals to I, and one more condition is there. What is that? Nums of I is less than or equals to pivot or not. If it is true, then move the ith element. I mean ith index. I index. And one more condition. This is for compare the right elements with the pivot. J is greater than or equals to low. And what is that next condition? Nums of j is greater than pivot. Then if it is true, then decrease this. After these two while loops, check the condition. If I is less than j, I mean this both I and j's are crossed or not. If it is crossed, then we have to swap the pivot element with jth index. Otherwise, swap the I and j, norms I and j. Why? Because if we found the any element that is in the left side, if you found the any element that is greater than the pivot, so what is the use of that? So already some low elements are, maybe in the future low elements are is there in the right side. So to bring that low smaller elements, first what you have to do, we have to swap from the starting itself. So that's why just move this higher element to the right. For that, here I am checking that. If it is I is less than or j, just swap those. If it is not, so in the left side there is no higher element. So why we have to do swap? So to restrict that condition, so I am using this condition here. If I is less than j, if it is I is less than j, just do the swap. Otherwise, just move forward. Okay. And after that, yeah, this I crossed j. So there is no restrictions, there is no conditions, no need. There is no need swap I and j. Just here we got the one partition, means pivot position we got here. What is that index? J index. So for that, in the right side, from the left side, we are going to checking the number of I is less than pivot. So already at the ith index, the elements are smaller than pivot. So that's fine. And also jth index, those are enough index. Those are enough compared to the pivot. Okay, there is an higher value is there. So I mean higher or lower value. So lower value compared to the pivot. So that is the pivot position. Okay. J means, because we are comparing this J element with the pivot. So this is the correct position for that pivot. So that's why we are changing the positions of jth index element and pivot. For that, what we have to do, just swap nums I comma pivot. Sorry, j comma pivot. Okay. This is an algorithm for that. Yeah, I hope you understood. First, let's see the one example problem. Then you can understand that. So already I have taken one example array. What is that array? 7, 3, something is there. What is that? Yeah. 7, 3, 9, 4, 9, 4, 8, 2, 6. Is this correct? Yes, this is correct. Yeah. Here, the pivot element is 7 and the low is 0. High is 0, 1, 2, 3, 4, 5, and 6. 6. Now, in the first method, what we are checking? Low is less than or low is less than high or not. 0 is less than 6. Is this correct? Yes. Then what we have to call? Then we have to identify the uh, pivot position. For that, we have to call quick method. In that, we are passing this low and high and also this array also. And there we are initializing two variables I and j. I is low, j is high, and one more element is there. What is that? Pivot. Pivot is equals to first element nums, or we can consider as array of low. What is that array of low? 7. Now first condition, while I is less than or I is less than j or not. 0 is less than 6 or not. Yes, it is true. Now after that, what we have to check? While I is greater than or equals to high and array of I is less than or equals to pivot or not. Then if it is true, just move the I. 7, 3, 9, 4, 8, 2, 6. Okay. This is an pivot. This is an low element. Min I and j. First condition. Nums of I is less than or equals to pivot or not. Nums of I means 7 is less than or equals to 7. Yes, it is true. Then just move this I to here, and after that nums of I is less than or equals to pivot. Nums of I means third element is less than or equals to 7. Yes, it is true. Then just move this ith index. Now 9 is less than or equals to 7. No, it's not true. So keep this I here. Next, check this another while loop. In that loop, nums of j is greater than pivot. So nums of j means 6 is greater than 7. No, it is not true. After this loops, one more condition is there. If I is less than j, what we have to do? We have to swap those I and j elements. Okay. Then after, what we will get? 7, 3, 6, 4, 8, 2, and 9. Here I index, here j index. Then again check this while condition I is less than j or not. Yes, it is true. Then again check it this. First left boundary with the pivot element. For that, what we have to do? Just to check this. 6 is less than or equals to 7 or not. Yes, it is true. Then just move this ith index. After this, 4 is less than or equals to 7 or not. Yes, it is true. Now just move this. Move forward. 8 is less than 7. No, it is not true. So just keep it here. Next, in the right boundary, check this condition. Like 9 is greater than 7. I mean, nums of j is greater than pivot or not. Yes, it is true. Just move this here. After this, again check this. 2 is nums of j. Nums of j means 2 is greater than pivot. No, not possible. So again, just swap those things. 7, comma 3, comma 6, comma 4, comma 2, comma 8, comma 9. I is this, j is this. Again check. Same condition. I is less than j or not. Yes, it is true. Just again check this left boundary. Like 2 is less than or equals to 7. Yes, it is true. So just move this I to here. And 8 is less than or equals to 7. Now keep this high here. And after this, right boundary. 8 is less than or equals, sorry, greater than 7. Yes, it is true. Then move this. After this, 2 is greater than 7. No. Now, what happened? Next condition will be false. Why? Because if I is less than j, we have to do swap of this I and j elements. But now it is false. Then what we have to do? This is the best position for this pivot. We got the best position of the pivot. Then swap those 2, comma 3, comma 6, comma 4, comma 7, comma 8, comma 9. Then now what will happen? We got the best position of this pivot. Then what we have to do? We have to do the recursion operation here. Just divide those boundaries, left boundary and right boundary. Now you have to check this 2, comma 3, comma 6, comma 4 and 8, comma 9. If you do this, then definitely you will get the same thing. Okay, 8, comma 9. So just focus on this. Here, this is one more thing. Again, we have to do this concept like pivot selection, pivot, selecting the pivot, and after that the left check and the right boundary check. Like same thing we have to do right now here. Here again, I is equals to this and j is equals to this. Here pivot is this and nums of I is also this. Nums of I is less than or equals to pivot. Yes, it is true. Then move this I to here. Again, check this. 3 is less than or equals to 2. No. Keep this high here. Just check with this right boundary. 4 is greater than 2. Yes, it is true. Just move this right to left. And 6 is greater than 2. Yes, it is true. Just move it here. And 3 is greater than 2. Yes, it is true. Just move it here. Yeah. Again check this. 2 is greater than 2. No, not possible. And next condition will be false. Because I is less than j is false. So don't do the swap of this I and j. Just do the swap of pivot and jth element. Because this is the best path, best correct position of the pivot. So that's why keep it here only. Then left part and right part, divide this. Here we will get 3, 6, 4. Here already swapped elements is there 7, 8, 9. Here now for now just focus on these 3 elements 3, 6, 4. This is an pivot. This is an ith position. This is an jth position. Same thing, just check this. 3 is less than or equals to 3. Yes, it is true. Just move this high. Then after 6 is less than or equals to 3. No, keep it here only. And this right boundary. 4 is greater than 3. Yes, it is true. 6 is greater than 3. Yes, it is true. Then move this high to, J to here. Then 3 is greater than 3. No, keep it here only. So this for this pivot, this is the best correct position for this pivot. So swap this pivot here. Then what we have to do? Divide this. So for now, what we will get? 2 comma 3, 6 comma 4, and 7 comma 8 comma 9. So focus on these two elements. 6 comma 4 is there. So this is an pivot, and this is an 8th position. This is an 8th position. Now 6 is less than left boundary for left boundary. 6 is less than or equals to 6. Yes, it is true. Just move this I2 here, and 4 is less than or equals to 6. Yes, it is true. Then I will move here to here. After this, in the while loop, we wrote one condition. What is that? I is less than or equals to I or not. So this condition will stop. Next, checking the value. Okay, this is false. I move it here. Then after that, jth value. What is that? 4 is greater than 6. No, not correct. So this is the best position for this pivot. So just swap those elements. 4 comma 6. Okay, just combine those things. This element with this. So then what we will get? 2 comma 3 comma 4 comma 6, 7 comma 8 comma 8 comma 9. So this is the sorted elements. Okay, is this correct? Is this clear? Yeah, I hope you understood the concept of quicksort with this example. If you're not, just comment it below, then I will explain clearly in the next video. Yeah, now just see the coding level right now. Already time completed. It's taking too much time to complete this video. So no problem. Just see this. After this coding, I will stop it. Yeah, let's see this. Here I have created one class, Pixar, and this is the main class, main method. Okay, now I am creating a one more method here, public, that will return, not will return anything, void this quicksort method. In this, I will pass array and into low and into high. In this, what we have to check in the initial level? Low is less than high or not. If it is true, just we have to find the partition. Partition means correct position of the pivot. For that, I am creating the one more method, that is pick. In that, I have to pass this array low, and high. Once we get that position, then we have to divide the array and we have to check left boundary again and right boundary again. For that, what we have to do? We have to use the recursion. Yeah, low partition minus 1. And after that, quicksort array comma partition plus 1 comma 5. Okay. After this, what you have to do? You have to write this another method. Pick. In this way, I will pass an array and integer low, integer high. In this, I am taking the pivot element here. Here, first I am taking the initial element as a pivot low, and another two variables are I is equals to low and int j is equals to high. Here I am checking the another condition. If I is less than j, then do the actions like checking the left boundary and the right boundaries. For that, I is less than or equals to high and also -1 also. Before the going to out of the state, just I am checking here. Array of I is less than or equals to pivot. Just move the I, and in the same way for the right boundary, j is greater than or equals to low -1, and array of j is greater than pivot, then move the j minus. After this loops, just check I cross j or not. If it is crossed, just do the swapping. What is that swapping? In temp is equals to array of I is equals to array of j, array of j is equals to temp. Okay. Then after this, what we have to do? After once it's done, we will get the one correct position of the pivot. So for that, what we have to do? We have to swap that position with the pivot. So in the same way, int temp is equals to pivot, not pivot. We can consider this one as array of j and array of low is equals to array of j and array of j is equals to low, array of low is equals to temp. After this, just return this j. I mean that position. Here missed this return type. After this, just execute this. So, non-static methods. So static. Yeah, got the solution. 2, 3, 4, 6, 7, 8, 9. Yeah, guys. This is one tutorial for this quicksort. I hope you understood the basics and theory part of the quicksort and also problem and with example for that, and also this coding with the Java. If you are comfortable with any other programming language, please let me know, guys. I will create another video with that language on this quicksort. Yeah, thank you, guys. Thank you so much for watching this video. If you are not yet subscribed my YouTube channel, please, I'm requesting you guys, please subscribe my YouTube channel. Thank you.